Good morning dear students, welcome back. I am your physics professor Dr. Nagaraj. So in this video I am going to start the discussion of sample question paper for triple E stream, applied physics for electrical, electronics and allied branches. So one thing I would like to clarify in the beginning itself, dear students, this is certainly not a model question paper. This is only sample question paper. I only have prepared the questions, selecting questions from each and every module and framed this paper. Okay, so this is the idea is to intention is to give some idea about the questions, pattern of the question and the type of the question and how much answer you are supposed to write. That is my intention behind making this video. So I don't claim that this is the question paper released by VTU. Definitely this is not a model question paper. This is only a sample question paper. But one thing I would like to tell you, these questions are covering whatever the questions I have selected are covering the entire syllabus for module 1 to module 5, and as per the pattern only I have selected. That means in the first module we have questions from modern physics and quantum mechanics, second module we have questions from lasers and like that. So module wise only I have selected. Fourth module Maxwell's equations, fifth module semiconductors. I have selected a question from each and every module, and each full question will be having three subdivisions A, B, C, and C is obviously numerical problem. Okay dear students, come without spending much time on introduction part, we will jump into the question paper pattern and the question straight away. See, this is nothing but question paper pattern. Duration is 3 hours, 100 marks, 5 full questions you have to answer, 1 question selecting from each module, and these are the constants given, physical constants given in the question paper. I think in addition to this you will be getting even formula handbook also. Okay, now coming to question number 1 from quantum mechanics. Set up one-dimensional time-independent Schrodinger wave equation. See, time-independent Schrodinger wave equation. I will solve this one now. Okay, so time-independent andre there should not be any t parameter in the final expression. Okay, the derivation goes like this. See, for any wave, not only matter wave, any progressive wave which is propagating in a given direction, we can write the wave equation in the differential form. It is like this: d square y by dx square is equal to 1 by v square into d square y by dt square, where y is a function of x and t and v is the velocity. Similarly we have wave equation for matter wave. This time in the place of y we have psi, because psi is the variable, is equal to 1 by v square into d square psi by dt square. Call this as equation number 1. And psi is a solution for this entire equation, and we can show that it is equal to a into e to the power of minus I omega t minus kx. This equation we need not have to derive, directly we can assume. Well, differentiate d psi by dt with respect to t. I told you we have to get rid of t because I want to derive time independent equation. That is equal to a into e to the power of minus I omega t minus kx as it is into minus I omega. That is once again d square psi by dt square is equal to a into e to the power of same as it is. I hope you know the fundamentals of differentiation. Into minus I omega whole square agutte. So that is d square psi by dt square is equal to minus omega square, because minus into minus plus, I into I square is again minus 1, because I is equal to root of minus 1, sorry, root of 1. Well, root of minus 1, sorry, not root of 1, I is equal to root of minus 1. So I square is equal to root of minus 1 whole square, that is equal to minus 1. Okay, so this I hope you know. Therefore, and this whole thing becomes psi. Call this as equation number 3. Substitute equation 3 in equation 1. We get d square psi by dt psi dx square is equal to 1 by v square into minus omega square psi. Okay, call this as equation number 4. Well, Please follow carefully. There are so many equations, already 4 equations we have. Okay, put V is equal to, this is velocity, V is equal to omega divided by K, where K is nothing but wave number, omega is nothing but angular frequency. Then d square by dx square is equal to minus omega square psi already there divided by V square. In the place of V square, I write omega by K whole square. Cancel omega and omega, and this becomes d square psi by dx square is equal to minus k square into psi, or d square psi by dx square is equal to minus k is nothing but 2 pi by lambda. So when I take the square, it becomes 4 pi square by lambda square into psi. Call this as equation number 5. So you must know what is k. K is nothing but a wave number. It is equal to 2 pi by lambda. Also, we know that lambda is equal to h divided by square root of 2m e suffix k anta baritini, where k stands for kinetic energy. Okay, so this is nothing but de Broglie equation. Therefore, lambda square becomes h square divided by 2mek. Okay na, that is equal to h square divided by 2m into kinetic energy plus potential energy is equal to total energy. So I want kinetic energy. Then what happens? It is equal to total energy minus potential energy. I repeat, kinetic energy is equal to total energy minus potential energy. So total energy I write it as E minus potential energy I write it as V. Yes. Now equation 5 becomes, therefore equation 5 becomes, please look at equation number 5. So substitute in equation number 5. Let us see what will happen. So d square psi divided by dx square is equal to, already minus 4 pi square is there, divided by, in the place of lambda square, I write h square divided by 2m into E minus V, this whole thing multiplied by psi. So that d square psi by dx square is equal to minus 2m goes to numerator, so it becomes 8 pi square m. E minus V goes to numerator, into psi is already in the numerator, divided by, in the denominator I have only h square. So finally d square psi by dx square plus, take this to the LHS, so it becomes plus 8 pi square m by h square, E minus V separately into psi, this is equal to 0. So this is our Schrodinger one-dimensional equation. One dimension because I have only dx square here. Time independent because in the final formula there is no t parameter. I hope you got this derivation. This is one of the important derivation, dear students. Okay, let me go to the next question now. Next question comes here. This is state and explain Heisenberg uncertainty principle and principle of complementarity. You know what is Heisenberg uncertainty principle? It states that it is impossible to measure both position and momentum to 100% accuracy if you try to measure them simultaneously. At a time if you measure, you cannot measure them with 100% accuracy, means accurate measurement is not possible. Always there will be some error. If you measure them individually, there will be no error. Simultaneously if you measure, definitely there will be some error. The product of the error is greater than or equal to h by 4 pi. This is the Heisenberg uncertainty principle statement. So here comes the statement. in the simultaneous measurements. I told you simultaneous ಆಗಿ ಮೆಷರ್ ಮಾಡಿದಾಗ, ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ಬರೀ ಪೊಸಿಷನ್ ಮೆಷರ್ ಮಾಡಿದ್ರೆ ನೋ ಪ್ರಾಬ್ಲಮ್, ಬರೀ ಮೊಮೆಂಟಮ್ ನೋ ಪ್ರಾಬ್ಲಮ್. ಇಫ್ ಯು ಟ್ರೈ ಟು ಫೋಕಸ್ ಆನ್ ಬೋತ್ ಅಟ್ ಎ ಟೈಮ್, you will end up with some error only. That is why Heisenberg says, in the simultaneous measurement of both position and momentum of the particle, there is always some error. Product of the error in the position and in the momentum is greater than or equal to h by 4 pi. So that is delta x into delta p greater than or equal to h by 4 pi. This is not only for position and momentum, even for energy and time also. That also I have mentioned there. That is not only delta x delta p, even delta e into delta t is also greater than or equal to h by 4 pi. Now principle of complementarity. What actually principle of complementarity? Actually first came principle of complementarity, then came uncertainty principle. Principle of complementarity was proposed by Niels Bohr. PUC ನಲ್ಲಿ Bohr's theory of hydrogen atom ಅಂತ ಓದಿದಿರಲ್ಲ, same physicist gave the principle of complementarity. It is like this. Bohr's complementarity principle states that a single quantum can exhibit a particle like nature or a wave like nature. Quantum particle antandre it can be atom or electron, proton, neutron, molecule, ion. Any smaller dimension objects are quantum particles only. So ಹೇಳ್ತಾನೆ it can exhibit either particle behavior or wave behavior at a time. At a time you cannot have both of them. So particle behavior or wave behavior is exhibited by the quantum nature, quantum setup. Okay, this means that we need distinct experimental arrangements in order to measure the particle or wave nature of the physical system. So that means a particle can either exhibit particle behavior or wave behavior. Any one behavior it will exhibit at a time. Okay, even though it has got both of them, okay, dual nature anta karitivi, at a time it can behave like either particle or a wave. For example, photon is a particle as well as wave. When it is propagating, photon behaves like a wave. At the time of emission, it behaves like a particle. Now, at the time of emission, if you want to check its behavior, you conduct separate experiment, particle related experiments. During the propagation, if you want to know its wavelength, frequency, etc., conduct wave related experiments. That is what the principle of complementarity states. So this means that we need distinct experimental arrangements in order to measure particle nature or wave nature. When importance is given to the particle nature, it will suppress the wave nature. If the importance is given to the wave nature, it will suppress the particle nature. This is known as complementarity. Andre, if you focus more on the wave nature, you lose information about particle nature. Similarly, if you focus more on the particle nature, you lose the information about the wave nature. See, for example here, particle position is the property of the particle, right? Like see, when I call something as particle, some parameters will come to your mind. What are all the parameters come to your mind? Position, mass, momentum, kinetic energy, volume, density, well, particle, charge, spin, these are all particle related properties. When I call something as wave, what are all the things will come to your mind? Frequency, amplitude, intensity, wavelength, phase, time period, all these things will come to our mind. If you name something, some parameter will tick to your mind. So for example, I name Sachin Tendulkar. What comes to your mind? Sachin Tendulkar and takshana what will come to your mind? Cricket will come to your mind. Like that, if I name Mysore Pak, what will come to your mind? It is a famous sweet of Karnataka. Itara. So when you name something, some parameters will immediately tick your mind. Like that, if I call this as a particle, what will come to your mind? What is the length of this pen? What is the color of the pen? Ink color, or whether it is a gel pen or ink pen, or what it is, or what is the price of this, or what is the mass of this. Ee tara barta hogutte. So when you concept like that, even in macroscopic domain, it is not a big issue at all. Particle is particle, wave is wave. But microscopic domain alli aa tara alla, particle ಜೊತೆಗೆ ವೇವು ಇರುತ್ತೆ, ವೇವಿನ ಜೊತೆಗೆ ಪಾರ್ಟಿಕಲ್ ಕೂಡ ಇರುತ್ತೆ. ಹಾಗಾಗಿ ನಾವು ಬಹಳ ಕಾಶಿಯಸ್ ಆಗಿರಬೇಕು. ಇಫ್ ಯು ಫೋಕಸ್ ಓನ್ಲಿ ಆನ್ ದ ಪಾರ್ಟಿಕಲ್, ಯು ಲೂಸ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಅಬೌಟ್ ದ ವೇವ್ ನೇಚರ್. ಇಫ್ ಯು ಫೋಕಸ್ ಓನ್ಲಿ ಆನ್ ದ ವೇವ್, ಯು ಲೂಸ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಅಬೌಟ್ ದ ಪಾರ್ಟಿಕಲ್ ನೇಚರ್. ಸೊ ವೇವ್ ವೇವ್ ಕಡೆ ಗಮನ ಕೊಟ್ಟರೆ ಪಾರ್ಟಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಸಪ್ರೆಸ್ ಆಗುತ್ತೆ, ಪಾರ್ಟಿಕಲ್ ಅಂತ ಟ್ರೀಟ್ ಮಾಡಿದರೆ ವೇವ್ ನೇಚರ್ ಸಪ್ರೆಸ್ ಆಗುತ್ತೆ ಅಂತ ನಮಗೆ ಬೋರ್ ಹೇಳ್ದ. ಇದನ್ನೇ ಸ್ವಲ್ಪ ಮಾಡಿಫೈ ಮಾಡಿ ಇವನು ಹೈಸನ್ಬರ್ಗ್ ಅನ್ಸರ್ಟಿನಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್ ಅನ್ನ ಹೇಳ್ದ. ಸೊ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಕಾಂಪ್ಲಿಮೆಂಟಾರಿಟಿ ಅಂದ್ರೆ ಇಷ್ಟೇನೆ, ಎನಿ ಕ್ವಾಂಟಮ್ ಪಾರ್ಟಿಕಲ್ ಆರ್ ಎನಿ ಕ್ವಾಂಟಮ್ ಸಿಸ್ಟಮ್ ಬಿಹೇವ್ಸ್ ಲೈಕ್ ಪಾರ್ಟಿಕಲ್ ಆರ್ ವೇವ್. At a time it can either behave like a particle or can behave like a wave, and when you focus more on particle nature it will suppress the wave nature. If you focus more on the wave nature it will suppress the particle nature ಅಂತ ಕಾಂಪ್ಲಿಮೆಂಟಾರಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್ ಹೇಳ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ನಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದೀನಿ, ಆನ್ಸರ್ ಅನ್ನು ಕೊಟ್ಟಿದ್ದೀನಿ. ಐ ಹೋಪ್ ಯು ಗಾಟ್ ದಿ ಮೀನಿಂಗ್ ಆಫ್ ದಿ ಕಾಂಪ್ಲಿಮೆಂಟಾರಿಟಿ. ಯು ಕ್ಯಾನ್ ಪುಟ್ ಇಟ್ ಇನ್ ಯುವರ್ ಓನ್ ವರ್ಡ್ಸ್. 2 ಲೈನ್ ಅಲ್ಲಿ ಬರೆದ್ರೂ ಸಾಕು, ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಅದನ್ನ ಹೆಂಗ್ ರೆಡ್ಯೂಸ್ ಮಾಡ್ತೀರಾ ನೋಡಿ, ಇಲ್ಲ ಆನ್ಸರ್ ಅನ್ನು ಕೊಟ್ಟಿದ್ದೀನಿ. ಆಮೇಲೆ after I finish all these questions I will share the PDF of the notes and the question and answer. You download it and practice because your examinations are fast approaching. So I will try to finish off within 1 or 2 days. Today as many videos as possible I will do and I will upload. Okay, well, now comes the numerical problem. An electron of kinetic energy 500 electron volt is in vacuum. Calculate the group velocity. Group velocity ಅಂದ್ರೆ particle velocity ನೇ. Matter wave ಗೆ 2 ತರದ velocity ಇರುತ್ತೆ, phase velocity and group velocity ಅಂತ. Phase velocity we ignore because it is very much greater than speed of light, so there is no meaning for phase velocity. So only group velocity. Group velocity is nothing but velocity with which a particle is traveling. And de Broglie wavelength also we have to calculate. Assume that mass of the electron is equal to the rest mass. Andre it is nothing but 9.1 into 10 power minus 31 ಅಂತ assume ಮಾಡ್ಕೊಳ್ಳಿ ಅಂತ ಹೇಳಿದ್ದಾರೆ. Okay, now let us start the numerical problem. The first equation, that is for that is for velocity of the particle. See, you know kinetic energy. Of course, energy is in electron volt. I have to convert that into joule. 500 into 1.6 into 10 to the power of minus 19. Okay, that is 800 into 10 to the power of minus 19 joule. Now kinetic energy is equal to half mv square. So please do small algebraic calculation so that v becomes 2 times kinetic energy divided by mass. That is equal to root of 2 into 800 into 10 to the power of minus 19 divided by mass is 9.1 into 10 power minus 31. Well, I do the calculation for you. It is 2 into 800 to the power of minus 19 divided by 9.1 to the power of minus 31. And after I take the square root for this, answer comes out to be 13.26. 13.26 into 10 to the power of 6 meter per second. So this is the group velocity or particle velocity. So first part is over. Now coming to the second part, lambda is equal to h divided by p or h divided by 2me, which is nothing but kinetic energy. I already mentioned this equation in the previous slide. That is 6.62 into 10 power minus 34 divided by square root of 2 into 9.1 into 10 power minus 31 into kinetic energy is 800 into 10 power minus 19. Dear students, one thing I tell you, please do the substitutions. ನೀವು substitution ಮಾಡಿದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಆನ್ಸರ್ ಬರೆದ್ರೆ 1 ಮಾರ್ಕ್ ಲೂಸ್ ಆಗೋ ಚಾನ್ಸ್ ಇದೆ. ಯು ಮೇ ಲೂಸ್ 1 ಮಾರ್ಕ್. ಪ್ಲೀಸ್ ಡೂ ದ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್. ದಟ್ಸ್ ವಾಟ್ ಐ ಆಮ್ ಡೂಯಿಂಗ್ ಹಿಯರ್. ಆಯ್ತಾ? ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಅನ್ನು ಒಂದ್ಸತಿ ತೋರಿಸಿ ಆಮೇಲೆ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟರ್ನ ತಗೊಳ್ಳಿ. 6.62 to the power of minus 34 divided by square root of 2 into 9.1 to the power of minus 31 into 800 to the power of minus 19. Close the bracket. It comes out to be, just sorry, one mistake I did. Well, first I will do 2 into 9.1 to the power of minus 31 into 800 to the power of minus 19. For this I take the square root. Now I take it to the numerator. Now I multiply by 6.62 to the power of minus 34. Answer is 0.548 into 10 to the power of minus 10 meter which is nothing but 0.548 angstrom. I hope you are following. This is the answer for question number 1C. Well, let us move on to the question number 2. This is very important question, most expected question. Particle in one-dimensional box anta. Discuss the motion of a quantum particle in one-dimensional infinite potential well of width A. Also obtain the eigenfunction and eigenvalue. Eigenfunction andre proper wave function anta. It should not be negative, it should be single valued, it should not be imaginary, it should be continuous, it should be finite. ಈ ತರ ಎಲ್ಲ ಪ್ರಾಪರ್ಟೀಸ್ ಇದೆ. ಈಗ ವೇವ್ ಫಂಕ್ಷನ್ ಅಂದ್ರೆ ಏನ್ ಗೊತ್ತಾ? It is nothing but probability of finding the particle at a given place at a given time. Probability cannot be imaginary, probability cannot be negative, probability cannot be infinity. So ಹಾಗಾಗಿ ವೇವ್ ಫಂಕ್ಷನ್ cannot be infinity ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಯಾವ ವೇವ್ ಫಂಕ್ಷನ್ಗೆ ಎಲ್ಲ ಪ್ರಾಪರ್ಟೀಸ್ ಇರುತ್ತೋ ಅದನ್ನು ನಾವು ಐಗನ್ ಫಂಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಆ ಐಗನ್ ಫಂಕ್ಷನ್ ಅನ್ನು ಉಪಯೋಗಿಸ್ಕೊಂಡು ಯೂಸಿಂಗ್ ದಟ್ ಐಗನ್ ಫಂಕ್ಷನ್ ಇಫ್ ಯು ಡೂ ಸಮ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ you will get energy value, momentum value, spin value, etc. Those values are called as eigenvalues. Now we consider one particle. That particle may be electron, may be proton, may be neutron, may be atom, ion, molecule. ಯಾವುದೋ ಒಂದು particle. Assume that the particle is present in a box ಅಂದ್ರೆ ಒಂದು ಪೆಟ್ಟಿಗೆನಲ್ಲಿದೆ. That box is considered as a well. So look at this diagram. This is the well and that black dot is particle. That well is of infinite depth. ಕೆಳಗಡೆಯಿಂದ ಮೇಲಕ್ಕೆ ಹೋಗೋದಾದ್ರೆ infinite height ಅಂತ ಕೂಡ ಕರಿತೀವಿ. Width is finite. So width is finite, height is infinite and particle is inside the well. ಇದು ಒಂಥರ ಹೆಂಗೆ ಅಂದ್ರೆ ಒಬ್ಬ ಮನುಷ್ಯ ಬಾವಿ ಒಳಗಡೆ ಇದ್ದಾನೆ, ಬಾವಿ ತುಂಬಾ ಡೀಪ್ ಆಗಿದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. As long as that man is inside the well, his potential energy is 0. If he want to come out of the well, he has to possess infinite potential energy. Similarly here also, particle is inside the well. In order to come out of the well, it has to possess infinite energy. Okay, some assumptions are made. Walls are rigid. We treat walls as rigid. So each time when the particle collides with the wall, it rebounds back immediately. It won't stay there. That means the wall is not made up of loose soil, mud soil alla. Collisions are elastic. If the collisions are elastic, immediately it will bounce back. Similarly, if the collision is elastic here, it will immediately bounce back. That means probability of finding the particle here and here, it is 0. Psi equal to 0 on this wall, psi equal to 0 on this wall. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಲ್ವಾ? So that means I am making some boundary conditions and as long as the particle is inside the well, potential energy 0, outside the well, potential energy is infinity. Right now my particle is inside the well, therefore probability of finding the particle outside the well is 0. So probability of finding particle inside the well not equal to 0. ನೋಡಿ ನಾನು ಇಷ್ಟೊತ್ತು ಏನು ಹೇಳಿದ್ದೀನೋ ಅದನ್ನೆಲ್ಲ ವರ್ಡಿಂಗ್ಸ್ ಅಲ್ಲಿ ಬರೆದಿದ್ದೀನಿ. In this model, a quantum particle, maybe electron, proton, ಯಾವ್ದು ಬೇಕಾದ್ರೂ ಆಗಿರ್ಬೋದು, is assumed to be trapped in a one-dimensional potential well of infinite height and width of A. Its walls are extremely hard. ಅದನ್ನೇ ನಾನು ಆಗಲೇ ಹೇಳಿದ್ದು. ಆಮೇಲೆ potential energy of the particle is 0 inside. ಆಗಲೇ ಹೇಳಿದ್ನಲ್ವಾ? And particle is restricted to move only along x-axis. That is why it is called as one-dimensional potential well. ಬಾಕ್ಸ್ ಒಳಗಡೆ ಪಾರ್ಟಿಕಲ್ ಬರೀ ಹೀಗಷ್ಟೇ ಮೂವ್ ಆಗ್ಬೋದೇ ಹೊರತು ಹೀಗೆ ಎಲ್ಲ ಮೂವ್ ಆಗಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. That type of assumption or that type of condition I am imposing on the particle. Now, whatever I have explained, whatever the wordings are there, are in the form of equations now. These are the boundary conditions. Number 1, psi equal to 0 and v equals infinity outside the potential well. ಅಂದ್ರೆ ಹೊರಗಡೆ particle ಇಲ್ಲ, particle is not there, psi equal to 0. Outside particle's potential energy is infinity. Of course particle is not there. If at all it want to come out, it has to possess infinite energy. Next thing, psi equal to 0 and v equal to 0. Sorry, psi is not equal to 0, v equal to 0 inside the potential well. That is correct. ಒಳಗಡೆ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಇದೆ, therefore probability is not equal to 0. And next one, psi equal to 0 at this place, that is at x equal to 0, and at this place, that is at x equal to a. Well, I have imposed boundary conditions. Now after imposing boundary conditions, take the first case. Outside the potential well discuss ಮಾಡೋಣ. Outside the potential well, v equals infinity. V equals infinity ಆಗಿರೋದ್ರಿಂದ now recall your Schrodinger wave equation. See, Schrodinger wave equation is here. It is E minus v. This is d square psi by dx square and 8 pi square m by h square E minus V into psi. In the place of V I am substituting infinity, so I get this equation. Look at RHS of this equation. RHS is 0, therefore LHS must be 0. Then only I can take that equation as a proper equation. Now the question, when LHS also becomes 0, what might be the possible value for psi? Think ಮಾಡಿ ನೋಡೋಣ. psi value ಎಷ್ಟು ಹಾಕಿದರೆ LHS also becomes 0? Yes sir, it is psi equal to 0. Only possible solution is psi equal to 0. Yes, you are correct. If I put psi equal to 0 on LHS, then whole LHS also becomes 0. See, E minus infinity into 0 is 0. Differentiation of 0 is 0. 0 plus 0 is 0. ಅಂದರೆ RHS and LHS become equal only when psi is 0. Now the question, whether psi equal to 0 is an acceptable solution or not. ಅಂದರೆ ಅದನ್ನು ನಾವು accept ಮಾಡ್ಕೋಬಹುದಾ? Yes, you can accept. Why? Because psi equal to 0 means there is no particle outside the well. Yes, we know that. ಅಂದರೆ what assumption we made, we are proving it mathematically. So whatever the assumption or whatever the condition you imposed is cross verified from this Schrodinger wave equation. So overall conclusion, outside the well psi equal to 0. This is case 1. Case 1 is not a big thing. That is too important alla. Most important is case 2. Even now also you will get psi equal to 0 mathematically, but you cannot take psi equal to 0 now. Why? Because if you take psi equal to 0 now, it means there is no particle. But question ಅಲ್ಲೇ ಹೇಳಿದರೆ particle box ಅಲ್ಲಿ ಇದೆ ಅಂತ. ನೀನು ಅದನ್ನ particle box ಅಲ್ಲಿ ಇಲ್ಲ ಅಂತ ಅಂದ್ಬಿಟ್ರೆ you get big 0 answer. Sorry, 0 marks. So psi equal to 0 is not an allowed solution now. Anyway, look at the calculation now. Inside the well V equal to 0. So therefore your Schrodinger wave equation will take this form. Dear students, please practice this derivation. This is most expected question. 10 marks ಗೆ ಬರೋ ಚಾನ್ಸ್ ಇದೆ. ಬರಲಿಲ್ಲ ಅಂದ್ರೆ don't put blame on me, but ನನ್ನ observation ಅಲ್ಲಿ ಇದು ಸಾಕಷ್ಟು ಸತಿ ರಿಪೀಟ್ ಆಗಿದೆ in the previous question papers also. Okay, now this equation becomes 8 pi square m by h square E into psi. That 8 pi square m by h square into E and I will take it as k square. Then your Schrodinger wave equation will take this form. Now for this equation we have a solution. Already in Schrodinger equation derivation I mentioned one thing. Solutions we borrow directly. It is not our job. It is mathematics teachers' job. They will teach you how to find the solution. In physics derivation, even in the valuation also, we will not expect the solution derivation. Directly solution you can write. Idenappa sir direct ಆಗಿ ಬರೀತಿದ್ದಾರೆ ಅನ್ಕೋಬೇಡಿ, ಬರೀರಿ, it is allowed. Marks will not be deducted for that. Okay, psi is equal to c cos kx plus d sin kx, where c and d are constants. C may be 0, may not be 0. D may be 0, may not be 0. Let us find out the C and D value. Already we have K value here. Now if you find C and D value, that will be the solution for the final wave function. Answer for the final wave function. Okay, now let us go like this. Psi is equal to c cos kx plus d sin kx. I want to find C value. Put x is equal to 0 and psi equal to 0. This is first boundary condition. When you put x is equal to 0 here, this becomes a cos 0. This becomes a sin 0. Anyway, sin 0 is 0, cos 0 is 1. Allige psi is equal to c into 1 plus d into 0. So c is finally 0. That is 0 is equal to c plus 0. So 0 is equal to c. Andere I have c value. I told you, no, c may be 0, may not be 0 anta helide. See, I got c as 0. Now I can say d cannot be 0. Sir, why? Why d cannot be 0? By chance if d is also 0, what happens to the wave function? Follow carefully. Involve. Psi is not equal to 0 inside the box. Olagade psi cannot be 0. If psi can be 0 inside, the whole discussion is of a waste exercise. So psi equal to c cos kx plus d sin kx. Even though it is a solution, c and d both cannot take values zeros. C can take, D cannot. By chance D takes 0, C cannot. Any one of them can be 0 but not both. Early, let us see what is the D value. Now again I put the boundary condition. This time I put another boundary condition. Earlier I took this wall x is equal to 0. Now I am taking this wall, that is x is equal to a. When I put x is equal to a, psi equal to 0. So why x equal to a, psi equal to 0? I told you, no, dear student, this wall is hard, rigid. When particle hits, immediately it will bounce back. It won't stick to the wall. Immediately it will return. Hogutte, dicky hodiyutte, pat anta vapas barutte. Hagagi here you cannot find the particle. Probability is 0 here. So when x equal to 0, psi equal to 0. When x equal to a, psi equal to 0. So after putting that boundary condition, I get d sin k equal to 0. Please follow the steps. D cannot be 0, I told you. Therefore, sin Ka equal to 0. When sin Ka equal to 0, Ka must be sin inverse of 0. And sin inverse of 0 is n pi. Therefore, K is equal to n pi by A. Where n is 1, 2, 3, etc. Now from equation 2 and 3, that means in the previous slide I wrote k value, k square is equal to 8 pi square me by h square anta bardide alva. That is k square, 8 pi square me by h square is equal to k whole square, that is n pi by a whole square, because I already proved k is equal to n pi by a. Now I making small arrangements or alterations here. I end up with this formula En is equal to n square h square by 8 ma square. Because I have n here, I write n even here also. N can take values from 1 onwards. If you put n is equal to 1, it corresponds to lowest energy, ground state energy. That is also represented by E0. E0 is called ground state. If you put n is equal to 2, it corresponds to first excited state. N is equal to 3, second excited, third excited, fourth excited, and so on. Okay, so better you write E naught value or the E0 value, that is h square by 8 ma square. This is nothing but ground state energy anta bariri one step. After that, now you go back to this equation. You know C value is 0. You know K value, you don't know D value. Therefore, D it is as it is. Sin K is now n pi by a. So I have psi n is equal to D sin n pi by a into x. But still I don't know what is the value of D. One thing I know, D cannot be 0 stay, but I have to find out the D value. Normalization is the best method for finding the D value. What is normalization? This is normalization. Integral of modulus of psi square. Actually square should be outside the modulus sign. By mistake it is inside. Please do the correction. Psi n whole square, after modulus it is whole square, into dx equal to 1. What I mean to say, this square is there, it should be somewhere here. Actually. Okay, now put for psi n, that is d sin n pi by a. So then it becomes d sin n pi by ax whole square, and then it becomes d square sin square theta. This whole thing I call as theta into dx is equal to 1. Now you know sin square theta is equal to 1 minus cos 2 theta by 2. I make the trigonometric identity. Meanwhile I take d square outside. 1 minus cos 2 theta, this whole thing is theta divided by 2, the divided by 2 is here, into dx is equal to 1. If you want, you can pause this video and simplify this derivation. It is a PUC level problem. It's a integrate this particular part. This is a very simple integration. Anyway, I will do it for you. I split it. Integral of dx minus integral of cos theta. Theta is 2n pi by a into x into dx. After integrating and applying the limits, just I display. You please try to go through the steps and convince yourself. This first one becomes integration of dx is x. Limits when I apply it becomes a minus 0. And this becomes sine. Integration of cos is sine. Sine of theta divided by coefficient of theta, and I already applied the limits. Upper limit is a, because 0 to a limits, 0 means left side, a means right side. 0 is this wall, a is this wall, and keep on simplifying. You get d is equal to root of 2 by a. Please follow the steps carefully. This sin 2n pi becomes 0, sin 0 becomes 0, and then this entire second term becomes 0. I left with only a. I'll get d square a by 2 matra udiyutte. D square a by 2 is equal to 1. I'll get d is equal to root of 2 by a. This is very lengthy problem. I think your teacher might have taken one period, maybe 2 hours also in your regular classes. Okay, so this is most expected question. Please practice this once again and once again and once again. Well, now substitute the d value in psi. You will get psi n is equal to root of 2 by a sin n pi by a into x. This is the eigenfunction. See, this is eigenvalue, this is eigenfunction. So this is eigenvalue, blue color, this is eigenfunction. So this is about question number 2a. Well, I will stop this video because it is becoming lengthy. Lengthy videos are not always catchy and always not attractive. So I will stop this. Immediately I will start the next video. I continue with the remaining things. Keep watching my videos and share your comments. Thank you, dear students.